Okay, so the last exercise in this chapter is exercise 306, components of a vector. So the unit vector on the x-axis is defined as I, as we've mentioned before, and the unit vector in the direction of the y-axis is defined as j. So we could write that I is equal to 0, 1. 1, 0, sorry, so 1 across, 0 up. And j is equal to 0, 1, so 0 across, 1 up. So we can actually write any vector in this component form. So if we've got xi plus yj, that's the same as x times I plus y times j, which equals xy. So for example, 4i minus 2j is the same as 4 minus 2 in that column matrix form. So it's just another way of writing it. So let's look at some of these numerically. So given that v equals 5 minus 3j and w equals 4 plus 2j, find v plus w. So that's pretty easy. There's our v, there's our w, and it's just collecting like terms. So 5i plus 4i is 9i, negative 3j plus a 2j is minus a j, sorry. So 9i minus j. The magnitude of v is exactly as we've seen before, Pythagoras' theorem. So we've got our 5 squared and our negative 3 squared, so that's root 34. The direction of v minus w. So first I'm going to find the vector v minus w. So I'm just going to subtract them. Again, I'm collecting like terms, so the 5i minus the 4i is I, negative 3j minus 2j is negative 5j. Now, it's always important to do a little sketch to see what quadrant that's in, and that is in quadrant 4. So we know when we're finding our direction which quadrant we're in. So tan theta equals the y over the x, so the negative 5 over the 1. Take the tan inverse, so tan inverse of negative 5, that gives us negative 78 degrees. It's giving us this angle, so we need to add 360, and it's 281.31 degrees.